Hi everyone. So this is the third lecture for the chapter Laws of Motion. In the first lecture, we discussed about the contributions of Aristotle and Galileo. So Galileo performed two experiments which concluded that no external force is required to keep the body in uniform motion in the absence of external forces. This was uh, this was based on Aristotle's laws of motion because he did not consider that frictional forces they are present in the nature, and so he simply concluded the his practical experience, his practical observation as a law, which was not correct. Then we have seen that Galileo's ideas they were used by Newton to give his first law of motion, which said that every body it continues to be in its state of rest or of uniform motion in a straight line unless some external force acts on it to change its motion. And this also gave a relationship with a relationship between the zero net external force on a body and the zero acceleration. So we also discussed this using several examples like a book is resting on the table, then it may seem that it is at rest, so there are no forces acting on it, but that is not the truth because as we have seen that the gravitational force, the weight of the book, that is always there, and so there must be some upward or some force acting in the upward direction just opposite to the weight of the book, and that was known as normal reaction force. And we also discussed the example of a person standing inside a stationary bus, and then the driver will suddenly start the bus. So the person gets thrown backward with a jerk. उसे झटका लग जाता है जब ड्राइवर अचानक से बस को स्टार्ट कर देता है तो वो पीछे की तरफ चला जाता है. एंड वी इसका रीजन भी हमने डिस्कस किया था कि हमारी बॉडी जो होती है वो तो डिफॉर्मेबल होती है, वो रिजिड नहीं होती. इस वजह से जब बस स्टेशनरी है, रेस्ट पे है, तो हमारा फीट जो कि कांटेक्ट बस के कांटेक्ट में है वो भी स्टेशनरी है, वो भी रेस्ट पे है मतलब. और जैसे ही ड्राइवर सडनली बस को स्टार्ट करेगा तो हमारा फीट लॉ ऑफ इनर्शिया की वजह से रेस्ट पे ही रहना चाहेगा, लेकिन जो हमारा अपर पोर्शन है वो रेस्ट पे ही रहना चाहेगा. और जैसे ही बस चलेगी तो बस के साथ में हमारी फीट तो चल देगी और हमारा अपर बॉडी वहीं पे रहेगा जहाँ पे पहले था ओरिजिनल पोजीशन में. इसी वजह से हमारा अपर बॉडी पीछे रह जाएगा और हमारी फीट आगे चली जाएगी. सो दिस वाज द रीजन वी आर थ्रोन बैकवर्ड. सिमिलरली वी आल्सो डिस्कस्ड व्हेन द मूविंग बस सडनली स्टॉप्स, तो हम लोग आगे हमें आगे को झटका लगता है. देन वी डिस्कस्ड अबाउट मोमेंटम ड्यूरिंग द Newton's second law of motion. So momentum is simply the product of mass of a body and its velocity, that's mv. Then we discussed the individual contribution, the individual effect of mass and the velocity v on the body, and also individually how time, that is a time duration for which that force is acting on a body, will also affect the actual motion of the body. So we concluded that the greater the change in the momentum in a given time, the greater is the force that needs to be applied to the body. And with respect to time, the time duration, that is delta t, we concluded that greater the rate of change of momentum, the force required is. We also discussed that the same force for the same time causes the same change in the momentum for the different bodies. So for different bodies means the masses of both the bodies are different. But if we are applying the same force for the same time duration, so even if the masses are different, so their final velocities will be different. But their change in the momentum would be same for both of the bodies. Then we discussed about the direction of momentum, that it is also in the direction in which the force is applied. And then we finally concluded the lecture by writing the second law of motion as Newton gave. So let me write down the second law of motion again. So this was the statement given by Newton for the second law of motion. The rate of change of momentum of a body is directly proportional to the applied force and is in the direction in which the force is applied. So this is the definition. And now we will use this definition to start a mathematical derivation and then end up with an expression which is relating the force and the acceleration of the body. So let's start the mathematical derivation. So let us suppose that a force F is acting for a time interval of delta t on a body of mass m and whose initial velocity is u or v. So what are the given conditions here? Force F acts for time duration delta t on a body of mass m whose initial velocity is, I'm sorry, initial velocity is v. So if the initial velocity is v and mass is small m, then we can calculate the initial momentum also. Initial momentum will be p mv. Simply multiply, simply product. And if we suppose that the final velocity is like there has been some change of velocity because the force is acting. So if force is acting, we know from the first law that if force will be acting, then there will be some kind of acceleration also. So that means the velocity will change. So if we consider the change in velocity as delta v, then the final velocity can be written as, final velocity will be v plus delta v. Delta v is the change in the velocity. So if final velocity is this, then we can write down the final momentum also. It will be m multiplied by the velocity. Now change in the momentum. So these steps you must see properly because these steps only you will have to follow in the numerical examples also. Because in the problems also when the velocity of any body will change from u to v, and you are asked anything related to the force or acceleration or momentum, anything, you'll have to, if you want to calculate the change in momentum, you'll have to deal in this way only. So the change in momentum is always written as final minus initial. It is not written as initial minus final because whenever we calculate the change of any physical quantity, we always take the final value as like before. So it's final minus initial. So final momentum, when we will open the expression, we will get mv plus m delta v minus initial was mv again. So this mv will cancel out and we will get m delta v. So this is the change in the momentum. Now look at the second law of motion statement. What it says is the rate of change of momentum. So we also discussed in the previous lecture that the rate of any quantity is simply that quantity divided by time. We discussed, no? We have written that expression also that the rate is equals to that quantity by time. So here also the rate of change of momentum of the body is directly proportional to the applied force. Just this statement. So if we write this statement mathematically, what we will say that force is directly proportional to the rate of change of momentum. So delta p is the change of momentum where we have calculated this. So this is delta p only. So delta p is the change of momentum and delta t is the time duration. So this complete expression is the rate of change of momentum and F is directly proportional. So this is what second law says actually in mathematical form. And so when some quantity is directly proportional, we can change this proportionality sign into the equal to sign by writing some constant of proportionality. So here we will take k. We can take any constant, doesn't matter. Delta p by delta t. Now in limit delta t was tending to 0. We had discussed this concept in the case when we were discussing the velocity and acceleration, right? कि जब when we take the limiting condition that delta t is tending to 0 or t is tending to 0, then this delta symbol it changes to small t. Like when time is very less, then because this delta quantity it includes a finite change that is from, like if we say from 10 to 5, so that's a finite change. And but when we take the very less time, we have to replace this delta symbol with d. So in this limiting case, it will be dp by dt. Now again, we will write the expression here. F is equals to k. P is written as mv k, because m is a constant, it will not change, no? So we can write m, take out m, and it will be dv by dt. And dv by dt is what? We discussed that the instantaneous acceleration quantity that we discussed, that is dv by dt is acceleration. So till here we get this expression. This means here k is a constant. It can be anything. It doesn't matter unless and until it is a constant value. So we can deduce that force applied on a body is proportional to the product of mass and acceleration of that body. It's proportional to. So this is k, no? So that's why we are using the term proportional to. So, but like for simplicity, we have always taken, because we needed a standard for signifying force, as if when we measure any quantity, we need a standard basis, no? That 1 centimeter means this much distance, or 1 kg means this much weight of a body. So similarly, here for simplicity and for measuring force in terms of numerical quantities, we have taken k to be 1. So when we take k equals to 1, this expression will reduce to F is equals to ma, and this is the final expression that we were talking about, no? That we'll finally go to an expression that will relate the force to be applied on a body and the acceleration of that body. So this is this expression F is equals to ma. Now we'll go forward to look some important points regarding this second law of motion. So what we wrote was F is equals to ma. Now you know that how to calculate the SI unit of any physical quantity. So if we want to determine the SI unit of force, what we will do is SI unit of mass is kg into acceleration is meter per second square. And so this whole thing, that kg meter per second square, is termed as Newton, because maybe because they have named it on the scientist that they derived all this. So we call the force as Newton. This is the SI unit of force, and its symbol is capital N. So that means like we say na ki if the weight of the body is if the mass of the body is 25 kg, so this is 25 is the magnitude, and kg is the unit. So that's the symbol. So if we will say that the force is 25 Newton, so we will say 25 Newton. Now some important points related to this second law are that second law is consistent with the first law, as using this law we can imply that when force is equals to 0, acceleration will automatically be 0, because the mass of any body cannot be 0, because if there is a body, even if there is a very small particle we are considering, it will have some kind of mass. So mass cannot be 0. So if force is 0, it will imply that acceleration of the body is 0. And this was the concept that we discussed during the first law. So this means that F equal to 0 implies A equals to 0, because mass cannot be 0. Now second law of motion, second point is, second law of motion is a vector law. That is, F is equals to ma is the overall expression, because acceleration is a vector quantity, so force must also be a vector quantity. That is meant by a vector law. So for simplicity, we can write, if we want to determine this thing for the x direction, we can write fx is equal to m ax, or in terms of momentum, if we want to write, will be dpx by dt. Similarly, in the y direction, fy will be equal to may is equal to dpy by dt. So we also discussed, when we were discussing the projectile motion, that these calculations, the calculations for the x and the y direction, they are independent of each other. I mean, we can say that we will have derived these three equations, and we wrote those three equations so for the for the motion in a plane into, we have broken down those three equations into two parts, for the x direction and for the y direction. Similarly, we will write it here also. So that means a force which is applied in some direction will change the component of velocity in that direction only, because acceleration ax. What does acceleration ax mean? Dvx by dt. So basically, when the force is applied in the x direction, the acceleration will also be there in the x direction. That means the velocity in the x direction will be changing with time. Also, we can say that the component of velocity which is normal to the force, it remains unchanged. So, as if in projectile motion, we were considering that acceleration was only in the negative y direction, that is, it was minus g, no? So, and this is acceleration in the y direction was minus g, and the acceleration in the x direction was 0. That means this acceleration in y direction will only change the velocity in the y direction, and it will not the velocity in the x direction will remain unchanged. And that is what we saw, because the velocity in the x direction was always constant. That was v cos theta, if you remember, that was always constant. So this is meant by a vector law. Also, the second law of motion is applicable to a single point particle. So F is the net external force on that particle, and acceleration, and E is the acceleration of that particle. But the law is also applies to a rigid body or a system of particles. A single point particle means, like, the mass is not distributed over the space. The mass is there at a point. It is all concentrated over that point. This is a single point particle, and it will have the force will be applied on that particle, and it will have some acceleration. But it is also to a rigid body, which consists of a system of particles. Then again, F will be the total external force on that system. See, uh, when we consider this F is equals to ma, we will all like the F will always include the internal forces in the system, are not to be included. Means, like, any of the internal forces will not be included, and F only has the external forces. Like we say that the external force due to gravity, that's a external force. I mean, any body, if something is happening inside that body, we will not consider that. So this point is very important. You must always keep this thing in mind. F includes only the external forces on the body. Internal forces are always to be are not to be included. Now, another thing is, important thing is that second law of motion is a local relation. Local relation means that the force F at a point in space at any instant of time is related to the acceleration at that point and at that specific time. In simple words, we can write it as कि किसी एक लाइक हम अगर स्पेस और टाइम ये दो चीजें कंसीडर करें, सो द एक्सेलरेशन जो भी उस एक पर्टिकुलर पॉइंट पे होगी, मतलब पर्टिकुलर लोकेशन पे होगी एंड पर्टिकुलर टाइम पे होगी, दैट लाइक दैट वुड बी रिलेटेड टू द फोर्स एट दैट पॉइंट इन स्पेस, और उसी टाइम पे, मतलब वो आसपास के आगे पीछे के टाइम पे डिपेंड नहीं करेगा और आगे पीछे के लोकेशन पे भी डिपेंड नहीं करेगा। मतलब जैसे सपोज करो हमने प्लेन बनाया कोई, एंड हम लोगों ने एक स्पेसिफिक लोकेशन बोला कि ये पॉइंट पी है जिसका कि कोऑर्डिनेट्स क्या है, एक्स कॉमा वाई। यहाँ पे लोकेशन फिक्स कर दिया एंड देन वी फिक्स द टाइम। हमने बोला कि टाइम इज इक्वल टू सपोज टाइम इज इक्वल टू बी से 5 PM। ठीक है, सो व्हाट वी डिड इज हम लोगों ने लोकेशन फिक्स कर दिया और हम लोगों ने टाइम को फिक्स कर दिया। सो दैट मीन्स कि force at this point and at this particular time, it will be related to the acceleration at this point and at this particular time. तो एक्सेलरेशन जो होगी, फोर्स और एक्सेलरेशन लोकल होते हैं टाइम के रिस्पेक्ट में और स्पेस के रिस्पेक्ट में। सो मतलब दे डू नॉट डिपेंड अपॉन एनी अदर टाइम कि पीछे पीछे वाले टाइम पे लाइक 4:30 पे क्या हुआ था, कितना एक्सेलरेशन था, इट विल नॉट डिपेंड अपॉन दैट, और इट विल नॉट डिपेंड अपॉन दिस neighboring point. So this is what the local relation means. Like if we want to write it mathematically, just for if you can understand, it's a function of x and t, and this f is related to the some function of acceleration at that particular x and t. This x and t and this x and t, they must be same. So local relation means independent of the history of the motion of the particle. So next we will. So these four, they were the some important points which were related to the second law of motion, which you must remember, keep in mind. Then we will discuss another topic, that is impulse. So this concept is applicable when a large force acts for a very short duration on a body, and even then it produces a finite change in the momentum of the body. For example, if we take that example of when we throw a ball towards a wall, दीवार की तरफ एक बॉल फेंकेंगे, so we'll observe कि बॉल जो है वो दीवार को हिट करेगी एंड इट विल कम बैक टू अस, इट विल बाउंस बैक। सो ये इसमें हम क्या ऑब्जर्व कर सकते हैं कि जो बॉल और वॉल का कांटेक्ट है वो बहुत ही कम टाइम के लिए है, मतलब दैट टाइम विल बी मीन इट इज नॉट इवन 1 सेकेंड। अगर आप घड़ी भी देखोगे सो इट इज नॉट इवन 1 सेकेंड, आप उसे बोल सकते हो 0.01 सेकेंड। तो ये टाइम ड्यूरेशन बहुत ही कम है। तो इसका मतलब है कि बॉल ने जो वॉल पे फोर्स लगाया, या ऑपोजिटली बोल सकते हैं कि वॉल ने जो बॉल पे फोर्स लगाया उसका टाइम ड्यूरेशन तो बहुत कम था, लेकिन वो फोर्स इतना ज्यादा था कि बॉल के मोमेंटम में फिर भी चेंज आ गया। कैसे चेंज आया? क्योंकि उसकी वेलोसिटी, आप देखो ना बॉल का डायरेक्शन बदल रहा है, दैट मीन्स मोमेंटम में तो चेंज आया ही है, क्योंकि वेलोसिटी में भी चेंज आया है, क्योंकि डायरेक्शन बदल रहा है। पहले बॉल मतलब वॉल की तरफ जा रही थी, बाद में बॉल वॉल से दूर जा रही है। So that means momentum, the direction is changing, velocity is changing, so momentum will also change. So there is a finite change in the momentum of the ball. This concept is known as impulse. So that force, that large force that is applied for a very short duration, that is known as the impulsive force. So let me write this first. You can take a note of it. When a large force acts on a body for a very short time duration, producing finite change in momentum. We discussed that example of ball when it bounces back after hitting the wall. Now, this is what's the theoretical definition. Now, if we come to the mathematical definition, so basically this impulse is what? It is the product of force and the time duration. Because see, force is very large, time duration is very small. So specifying each of them individually, it might be difficult. So what we do is we simply multiply these and we take the product of force and the time duration and we call it impulse. Now, when we were deriving the second law of motion, we also wrote an expression. What was the, let me write it here. Second law of motion was force applied on a body is directly proportional to the rate of change of momentum. No, this was the expression from which we started the derivation. And now what we do is we take delta t this side. F delta t directly proportional to delta p. So what is this? Delta p is the change in the momentum. Change in the momentum, that is m times v2 minus v1. And this f into delta t, that is also proportional to the change in the momentum. So we define impulse using this expression only. Impulse is force into time duration. So which is equal to force into delta t, and this value, using the second law of motion, it can also be written as delta p, which is change in momentum. So here you must remember, you must keep in mind that there are two ways of calculating impulse. I mean, if we are given the force and the time duration for which the force is acting, then we can calculate impulse as a whole, like using this formula F into delta t. And there is another way, that is calculating the impulse in form of change in momentum. So, so there are two ways of calculating impulse. First using F delta t and second using delta p. Obviously, these two expressions, they mean the same thing mathematically, but it's only the way in which the question is asked to you and the quantities that are given to you. So it can be calculated using these two methods. Now we will also discuss a few numerical problems related to the second law of motion and impulse. So write down the problem first. So the question says a bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a wooden block and stopped after distance of 60 centimeter. So the question is asking what is average resistive force exerted by the block on the bullet. So if this is a wooden block and a bullet is coming and it hits the wooden block and it enters to some depth, like suppose it will enter till here, and this distance is given as 60 centimeter. So the question is asking that what is the average resistive force which is exerted by the block, by the wooden block on the bullet. So for this, what we will say that mass is given to us. First, we always have to write what is given to us so that we have all the information. Initial velocity of the bullet is given to us. It is saying that the bullet is getting stopped after the distance of 60 centimeters. Stopped means final velocity is 0 and distance is also given as 60 centimeter. So like this is a kind of question that we practiced during the during the chapter law, the motion in a plane. So that there also we derived three formulas, no? Three expressions we derived for like these expressions, they were in terms of the initial velocity, final velocity, displacement, acceleration, time. So these expressions, they were in these in the terms of these 5 physical quantities. So now we have to get the acceleration. Why? Because for calculating the force, we must need acceleration. So we will first calculate acceleration using the third expression that we derived there. Here v square is 0 minus u square is 90. 2 into acceleration we don't know, and distance or the displacement we know. Thus acceleration would be 90 into 90 by 2 into 0.6. See, this negative sign comes because of the retardation, because we know that the velocity is decreasing and it finally gets the bullet is finally at rest. So that means this is the case of retardation. The negative sign only signifies retardation and nothing else. So when we get the acceleration using the second law of motion, we can write F is equals to ma. Mass was given as 0.04 kg. See, you should always see the units of the physical quantities that are given to you, because see, the question might give you mass in terms of gram also. Then you will have to convert it into kg, because acceleration is in terms of meter per second square. So the best way is to solve the question using the SI units, because that way you will never get confused to which unit has to be used where. Because see, here we had, the question had 60 centimeter, no? But we will not use centimeter because we are calculating in SI units. So SI units means in meters. So that is why we have used here 0.6 meters. So always just remember to convert the all the units which are given into the SI units only. On calculating this, Newton. This is N means Newton. The SI unit of force is Newton. Minus signifies retardation. So this was the question. We'll move to other question. So this question says, a batsman hits back a ball straight in the direction of the bowler. A batsman hits back a ball straight in the direction of the bowler without changing its speed. That is 12 meter per second. The mass of the ball has been given and we want to calculate the impulse imparted to the ball. So see what the question is saying. Suppose here the batsman is there and initially the ball was coming this way with some velocity, that's given, no, 12 meter per second. And when the batsman hits the ball, he will also hit the ball with the same velocity. Like the ball's velocity is again 12 meter per second, because the question says that the speed of the ball is not changing. So that's 12 meter per second again, but the direction has changed. So the direction of the velocity has changed and we want to calculate the impulse. So we discussed that. First, see what is given. 150 gram, velocity 12. So how to write down the velocity is, because we also discussed थोड़ी देर पहले हमने डिस्कस किया था कि वेलोसिटी का मैग्नीट्यूड भले ही चेंज हो रहा हो या ना हो रहा हो, लेकिन अगर उसका डायरेक्शन चेंज हो रहा है, दैट मीन्स दैट देयर इज अ चेंज इन द मोमेंटम हैपनिंग. ठीक है, क्योंकि मोमेंटम और वेलोसिटी ये दोनों वेक्टर क्वांटिटीज हैं, इसी वजह से हमें डायरेक्शन देखना बहुत ज़्यादा ज़रूरी है. तो अगर वेलोसिटी का मैग्नीट्यूड भले ही चेंज ना हो रहा हो, बिकॉज इट्स कांस्टेंट इन दिस क्वेश्चन, लेकिन उसका डायरेक्शन चेंज हो रहा है इन अ कम्प्लीटली ऑपोजिट डायरेक्शन, सो वी विल नॉट से दैट द वेलोसिटी इज कांस्टेंट हियर, क्योंकि अगर वेलोसिटी कांस्टेंट हुई तो हमारा मोमेंटम में चेंज हमने क्या देखा था, दैट वाज m डेल्टा v. सो डेल्टा v विल बी 0, दैट मीन्स द मोमेंटम इज 0, बट दैट इज नॉट ट्रू, बिकॉज वी कैन सी दैट द बॉल का डायरेक्शन चेंज हो रहा है, बॉल में फोर्स लगाया जा रहा है, दैट मीन्स कोई ना कुछ मोमेंटम चेंज जरूर हो रहा होगा. So that means we will not write the velocity as 12. What we will say is the initial velocity is, see, the ball is coming this way. So this is this might, you can consider it negative because this is the x-axis, no? So negative. It will be initial velocity is minus 12. We will write it this way. And final velocity of the ball is in this direction, opposite direction. So it will be plus 12 meter per second. And thus impulse, we discussed, it can be calculated using two ways, because यहाँ पे हमें डेल्टा टी मतलब टाइम ड्यूरेशन नहीं दे रखा है, so we cannot use that formula f into delta t. So what we will use the concept, the change in the momentum. Change in momentum is final momentum minus initial momentum. Sorry, let me write it as Vf. So this is Vf minus Vi. Okay. So here we will take out common because it's 0.15. See, the mass is given in grams. You must remember to change it into kg because we are calculating in SI units. So the final velocity is 12 minus the initial velocity is minus 12. So it will be 0.15 into 12 plus 12 is 24. And so the result would be 3.6 Newton second. See, this Newton second, where does it come from? We know how to calculate the SI unit of the quantities, right? So what is impulse? It is F into delta T. Like, and F is Newton, delta T is second. So this Newton dot second is the SI unit for impulse. Also, we can write it in terms of momentum also, because that is also a way to write down the unit because it implies the same thing. So we can write it in terms of the momentum also. That's kg meter per second. So that's also correct. That's also correct. ये भी सही है. kg meter per second भी लिख सकते हैं इम्पल्स के लिए और न्यूटन डॉट सेकेंड भी लिख सकते हैं इम्पल्स के लिए. Now coming to the last question for today. The question says, here the force has been given. अभी तक हमें force नहीं दिया जाता था. The force of 50 Newton is applied to an object of mass 5 kg. What is acceleration and velocity after 4 seconds? So here we know F, we know the mass. So from the second law of motion, we can calculate the acceleration, which is F by m. Acceleration is meter per second square, right? So this is the acceleration. Then the question is asking, what is the velocity after 4 seconds? So again, we will use our motion and plane formula. The simple one, the object is initially at rest, acceleration is 10 and time is 4. So it is 40 meter per second. So the final velocity is 40 meter per second after 4 seconds. Now, there was one more question I wanted to discuss related to the impulse concept because it contained that time duration thing. But as the time is not there today, so we'll discuss it in the next lecture. So we'll start with this question and then we'll move on to the Newton's third law of motion in the next lecture. So that's all for today. Thank you, everyone.